Hello. Can you guys hear me? Hi. Wait, because like all of your names are phone numbers, I don't like I can't tell like what your names are. So like after class, if you can, please like see if you can change your names on the app. And also, would you guys like mind turning on your cameras, please? Okay, thank you. So, I guess welcome to the first class. I'll do a short self introduction first. So, as you guys know, my name is Chris. I'm currently 13 years old and I'm from Shanghai American School. I guess I'll share some fun facts. I do a lot of swimming, and so some of my hobbies, I really like creative writing. So I do a lot of writing, and I also like to watch anime and listen to music. Yeah, that's pretty much it. But since we have like a lot to go through today, I might not be able to go through with like every one of your self introductions. So I guess we can just get straight into the class. Okay, so firstly, we're going to review the preview questions from last class. So, did you guys do them? If you did, like, you can raise your hand on the app. Oh, okay. So, I'm gonna open it up first, just in case. So, these preview questions, wait, let me see. These preview questions, did you guys do it? It's just to help like view what we're going to be doing for the class. So before we get into the actual content of the class, we can try to go over them together. And so for the first problem, I'll open up a short poll for you guys to do. I'm gonna open it up for 30 seconds. And you can read the question by yourself before we start the actual class, just so I know like what you guys know already. We still have a few more answers. Let's see. Okay, I'll end it. So I guess most of you got it right. It's D. Does anyone want, so like since it's at the start of the class, does anyone who know how to do it want to come up and explain? You can raise your hand. Okay. Wait, I'm gonna put you on stage, but I don't know your names because of your like the phone number. Could you unmute and tell me your name, please?
My name is Melissa.
Oh, okay. Wait, could you spell it? Huh?
Melissa.
Oh, okay. That's a pretty name. Do you want, so could you, let me see if I can grant you access to the board. Okay. think you can draw on the whiteboard now, so you can help explain to everyone about the problem.
So basically, what I just did is I just used use some numbers. So like blue, blue, and then red, green, yellow. And since it says that 1/3 of her marbles are blue and 1/4 of them are red, the number will be divisible by 3 and 4. So at first I tried the number 12, which would have blue as 4, red as red 3, and green 6, which would already be larger than 12, so that would not work. And so I just tried 24 next, and there would be 8 blue marbles, 6 red, 6 green, and 4 yellow.
Okay, perfect. So I'm gonna put you down first, and that's actually one of the solutions. I'll explain another solution that is a bit more efficient. I mean, this one is actually one of the quickest ways, but just in case, wait. Could you, hello? Hey, what's your name?
Hello. My name is Janissa.
Oh, okay. Do you want to explain another solution?
Yes, I have another solution. But I'm not able to speak English. Can I speak Chinese?
Yeah, sure.
So I speak Chinese. 首先他说有1/3是蓝色的，然后1/4是红色的。那我可以先将1/3加上1/4，得到的就是12/7。然后我设总数为1减12/7就等于12/5。然后我们现在知道，这个12/5是绿色和黄色所占总数的部分，所以我们就可以去试了。如果想要它最大的话，最好是绿色是是多少？最好是绿色是12/4，但是如果它是12/4的话，那它就是一个分数算出来，所以它只能是12/3，也就是1/4。然后6去除以1/4，得到它的总数是24。那24再去乘以12/2，也就是黄色的占比则是4。
好。Okay, perfect. So that's going to be both of the solutions for our first question. And since there are going to be a lot of previous questions, we're just going to go briefly to the next two, and I'll start explaining the concept. I'll give you guys a poll for this one too. And you can start. Okay, time's up. And again, most of you got it right. So for this one, I'll explain the problem. I'll explain the problem this time. And this one is pretty simple because at first Harold says that he was only able to eat 1/4 of the pie. So that means that there will be 1 minus 1/4 equals 3/4 of the pie left. Then a moose came by and ate 1/3, which meant that the moose would leave out 1 minus 1/3 equals 2/3. And the porcupine would also leave 2/3 of what the moose left behind. So that would be this equation, and we can get 3/4 times 4/9, which is 1/3, and the answer would be 1/3. So if we don't have any questions, then we'll move on to the last preview question, and okay, got the poll for this one too. Okay, great. So most of you guys chose E, which is the correct answer. And this time I'll again ask someone to come up and explain if you want. Again. You can explain in Chinese.
Thanks。我们现在知道了8年级比6年级等于5:3，然后8年级比7年级等于8:5。我们可以先把它画成三项的比，上是8年级比6年级两边同时乘以8就等于40:24。8年级比7年级两边同时乘上5就得到40:25。他们8年级比7年级比6年级则是40比上25:24，然后再将它们相加就得89个人。
Okay. Is this? Oh, is it 24:25?
40:25。
啊，对。Okay. 然后最后一步你再重复一遍可以吗？
可以。他们8年级比7年级比6年级就是40:25:24，再将它们相加。
OK， 好，谢谢。Right. And that is the most efficient way to solve this problem, and we get 89. Okay, so now that we've gone over the preview questions, I'm going to move on to the actual concept about fractions. So I'm going to put this here on the list. I believe that most of you guys already know what fractions are, but we're just going to do a quick review, okay, just in case. And so the basic of fractions are that basically there's going to be a number that is usually written in this form, x over y, and the expression that it is denoting is x divided by y. And the number on top is the numerator, while the number on the bottom is the denominator. So usually, because it's x divided by y, when the fraction is less than 1, then let's say it is usually a part of a whole. So let's use a basic example of a pie or a pizza. So let's say that the fraction is 3/4. Then we would divide the pizza into 4 parts, which is the denominator, the number on the bottom, and we would highlight, or we would take 3 of the pieces because the number on top is 3. And so that's pretty simple to understand. But there's also another point, which is, for example, we have 1/2 of a pie, so that would be 1/2. And let's say we draw the same pie with the same half, but if we divide it into more pieces like this, then now we have 8 pieces in total and 4 of them are highlighted. So the way that we denote this fraction would be 4/8, but they still have the same value because they're still the same part. They're from the same whole. So that means that if it's a fraction, if you multiply both numbers, the one on the top and the one on the bottom, by the same number, you would get something like, let's say we multiply this fraction by 2/2, then we would get 2x/2y, but in fact the value is still the same as x/y, if you get what I mean. And that reminds me of, and that will help us move on to the 4 basic operations of fraction. And firstly, it's going to be multiplication. Multiplication is the simplest. Basically, let's say we have 3/4 and 1/2. Then what you have to do is just multiply the 2 numbers on top and the 2 numbers on the bottom. And in this case, it would be 3/8. And now let's move on to division. And this is when something called reciprocals comes into play. Reciprocals are basically a fraction reversed. So let's say xy, then the reciprocal would be y/x. And the rules about reciprocals is that if two numbers are reciprocals of each other, then the product would always be 1. Let's say xy times yx would be 1. And so the thing that it had to do with division is, let's say 3/4 divided by 1/2, then the dividend would have to be switched as its reciprocal. So for example, for this one, it would be 3/4 times 2/1, which is 1/2 reciprocal. But since it's just 2 divided by 1, basically we can just divide 3/4 times 2, which is 6/4, and the same as 3/2. The reason that we do this is because, let's say we go back to this equation, then if you expand it, it would be 3/4 times 1 divided by 1/2, and this together is just going to be 2/1 because of this. So, and that's going to be the basic of dividing and multiplying. And again, if I'm speaking too fast, you can tell me, and if you have any questions. Next, we'll be moving on to adding and subtracting, which is a bit more complicated than multiplying and dividing. Because let's say we have 3/5 and 1/2, the denominators are not the same. Because the denominators are not the same, we can't add them directly, and we have to find a common denominator. And in this case, we just have to find the least common multiple. Which in this case is just going to be 5 times 2 equals 10. And what we have to do is basically convert both of these fractions denominators into 10, we can just do times this by 2/2 and times it by 5/5. So that'll be 6/10 plus 5/10 equals 11/10. And that is the same for subtraction, because adding and subtracting are basically the same. And similarly for this one, let's see, because we can see that the denominator is less than the numerator, which means that this fraction is greater than 1. And this would be something called an improper fraction. But the way we can also denote it as a mixed fraction. So the way that we denote it as a mixed fraction is that basically 11/10 is going to be 10/10 plus 1/10, and 10/10 is basically 1. So denoted as a mixed fraction, it's going to be 1 and 1/10. And we can also convert this back into an improper fraction by doing this 1 times the denominator equals 10 plus the numerator equals 11. And since the denominator was 10, we'll just put it under, and that's the basic of fractions. So that's going to be the basic for operations. And the last thing about fractions is converting it into other forms. So there are three main forms that fractions can be converted into, which are percentages, decimals, and ratios. Percentages are the most simple because it's basically just 1 over 100. Let's say we have 30%, then we would convert this into fractions by just 30 over 100, which when simplified is 3 over 10. And for decimals, let's say we have 0.91, then there are 2 digits after the decimal point, which means that this is going to be it's going to be out of 100. That means that for this number, it will be 91 over 100. Similarly, if we have like 0.111, there are 3 digits after the decimal point, which means that this is going to be 111 out of 1,000. And for since maybe like 1 digit after the decimal point, then that will be 3 over 10. And it'll be the same for every other decimal. And lastly, for ratios, it is quite simple. Let's say that we have a ratio of 1 to 2. And it depends on the context. So let's say that this is denoting 2 groups of people. So the first group of people, the amount of people in this group compared to the other amount, the ratio is 1 to 2. It means that the second group has twice as many people as the first group. And the way we denote it as a fraction is just 1 over 2, which is the first number over the second number. Do you guys have any questions? And if I'm speaking too fast, please tell me. So as there is no question, let's move on to the first exploration. So we'll be going over 5 main types of questions on fractions in the AMC tests. So the first type is going to be fraction-based relationship problems, which is usually the most simple one, but there are a lot of numbers. And basically what we're doing is describing how parts of a whole relate to each other using fractions while trying to focus on structural relationships rather than service level numbers. Because there is not going to be as much time during the actual exams, which we'll have to try to find the most efficient methods. So let's take this question as an example. The weight of 1/3 of a large pizza together with 3.5 cups of orange slices is the same weight of 3/4 of a large pizza together with 1/2 cup of orange slices. A cup of orange slices weighs 1/4 pound, and the question asks us the weight in pounds of a large pizza. So there are a lot of numbers here, but let's organize them out first because it might seem a little bit confusing. So firstly, it's just that a weight of 1/3 of a large pizza together with 3.5 cups of orange slices. So in this way, we can first substitute. So let's say that a large pizza is X and a cup of orange slices is Y, just to make it simpler. So it's just that 1/3 of a large pizza, which is just going to be 1/3 X plus 3.5 cups of orange slices, which is 3.5 Y. It's the same as 3/4 of a large pizza, which is X plus 1/2 Y. So it might seem a little bit complicated, so we have to first organize the equation and make like terms together, put like terms together. So we can move Y over here and X over there. And in that case, it'll be 3.5 Y minus 1/2 Y equals 3/4 Y minus 1/3, 3/4 X minus 1/3 X. Let's see. And by rearranging, we'll have 3Y equals 9 over 12x minus 4 over 12x. And that will be 3y equals 5 over 12x. And since we know what y is, as it says, we need to first isolate x. And in order to do that, we want to find 1x instead of 5 over 12. And as we learn about reciprocals, that would mean we just have to multiply it by 12 over 5. It's just on both sides. So this means that we finally get 36 over 5y is the same as x. And since we know what y is, a cup of orange slices weighs 1/4 of a pound. We just have to do 1/4 times 36 over 5 equals 9 over 5, which is the same as 1 4/5. So that would mean x equals 1 4/5, and we get our answer. Do you guys have any questions? So if there are no questions, then we can move on to a practice problem. Mrs. Jones is pouring orange juice into 4 identical glasses for her 4 sons. She fills the first 3 glasses completely but runs out of juice when the first glass is only 1/3 full. What fraction of a glass must Mrs. Jones pour from each of the first glasses into the fourth glass so that all 4 glasses will have the same amount of juice? I'm going to isolate it first and give you guys some time to think about it. Make sure you guys submit the answers after you're done. So for now, I'm gonna collect the answers, and yeah, so most of you guys who did it were able to get it correct, and I believe that you guys might need to try to work like a bit faster because in the exam it's not going to give you as much time. But now I'm going to explain this problem. It's quite simple. So let's first go over the problem. It says that Mrs. Jones is pouring orange juice into 4 identical glasses, so we can draw them just as a visualization. And she fills the first 3 glasses completely, but runs out of juice when the first glass is only 1/3 full. So that would be like this. This means that now we know she has 3 and 1/3 cups of orange juice in total. And she said that what fraction of a glass must Mrs. Jones pour from each of the first 3 glasses into the first glass so that all 4 glasses will have the same amount of juice. So firstly, we need to figure out how much each cups need to have. So that will be 3 and 1/3 divided by 4. But that would be a bit difficult, so we can convert this into an improper fraction first, which is going to be 3 times 3 plus 1 equals 10. And with the denominator 3, it'll be 10 over 3. So we would need to divide this by 4, which would also be 10 over 3 times 1 over 4, which is 10 over 12. And that would also be 5 over 6. So now we need to figure out like how much glass you need to pour out. And this has like 1 full cup. Each of the first 3 glasses has 1 full cup of juice. So in the end, it would be just 1 minus 5/6 equals 1/6. And that would be our answer. And that's all for our first section about fractions, like finding the relationship between fractions. Next, let's move on to the second type of question, which is going to be about repeated bouncing problems. These will involve a lot of calculation and multiplying. And it says that each bounce goes a part of the height from the last bounce, always the same fraction, and the height will keep getting smaller and smaller in a regular pattern. So these simple rules are basically bounce height equal to first bounce times the fraction that the problem gives you about how much the second bounce will fall to the height it reached in the previous bounce. So now let's do a practice problem, an exploration problem. So it says that a ball is dropped from a height of 3 meters. Let me first isolate it. So that would be like this. Let's say this is the ground and this is 3 meters. So the ball falls to the ground, and on the first bounce, it rises to a height of 4 meters. So it's gonna be like this. And it keeps falling and bouncing to 2/3 of the height it reached in the previous bounce. So it'll look something like this, all the way until it does not rise to a height of 0.5 meters. So, we can first start with multiplying 4 by 2/3 to get what the second bounce will be. So that will be 4 times 2/3 equals 8 over 3. And 8 over 3 is obviously not less than 0.5 meters, so we just have to keep multiplying all of these numbers by 2/3 until we get something that's less than 1/2. So let's say put 1/2 here, and this would be the first bounce first, and this would be the second. So now we just have to keep multiplying. Multiply by 2/3 equals 16 over 9 by 2/3 equals 32 over 27. And again, 64 over 81. And again, to get 128 over 243. So it's getting more and more complicated. And we can see that maybe 128 over 243 is getting close to 1/2. But then we see that 128 times 2 is greater than 243, which means that it is still more than 0.5 meters. So lastly, we can do one last multiplying to get 256. over 400 and over 729. So now we can see that this is obviously less than 0.5 because 256 times 2 is less than 729. So this will be our final answer. But now what we have to do is just count the bounces. That would mean 1 bounce, 2 bounces, 3 bounces, 4 bounces, 5 bounces, 6 bounces, and 7 bounces. So in the end, our answer, excuse me, is going to be 7. Do you guys have any questions? So it's basically just repeated multiplying in something like a geometric sequence. But because it's fractions, the calculation might get a bit intense, even though it actually isn't hard. So we can do a practice problem now, and it's going to be a bit simpler. A bar is dropped from a height of 4 meters. On the first bounce, it rises to a height of 2 meters, and it will keep falling to half of the height it reached in the previous bounce. And again, we want to know on which bounce it will not rise to a height of 1/2 meters. I'll give you guys some time to think about it as well. And remember, it says it will not rise to a height of 0.5 meters, which means it has to be less. Okay, perfect. We have a bit more people who got it done, and most of you guys are correct. So, since this is a pretty simple question, does anyone want to come up and explain? You can give some more people some chances. Okay.
Okay, so on the first bounce, it rises to a height of, say, 2 meters. And on the second bounce, it will be like half of 2, which will be 1 meter. And 1 divided by 2 is 0.5. So the next bounce will definitely be smaller than 0.5.
Okay, thank you. So this one is a pretty easy one. And in the end, if you count the bounces, it's going to be 1, 2, 3, 4, 5. Wait. Oh, sorry. It's going to be 1, 2, 3, and 4. So that would be 4 bounces. And we have another practice problem, in fact. But for this one, it will also start from the first bounce of 4 meters. And at the end, we want it to get to 0.5 meters, and for this one it will keep falling and bouncing to 2/3 of the height. So it's basically the exact same as the problem I explained in the equation, and the answer will be 7. So we'll skip the detailed explanation on that one. And now we can move on to our third exploration. So I'm going to explain one of the problems, and you guys can take a 5-minute break. So basically the type of problems that we're going to be doing is equal parts from unequal groups, and there are going to be 2 percentages or fractions from both groups, while the 2 groups add up to a known total. So a known percent is going from each group is going to form equal parts, and we want to use this relationship to set up an equation and solve for the group's individual sizes. So I feel like if you read these type of problems, it's going to get a little bit confusing, so I'll try to explain as well as I can. Sorry. The problem says that in an extracurricular program for junior high and senior high students, there is a science competition group. So there will be an extracurricular program, and inside there's going to be a science group. So the number of junior high students and senior high students in the group is equal. So we'll list junior high and senior high students down. Among the 26 students participating in the program, 20% of the junior high students and 12.5% of the senior high students joined the science competition group. How many senior high school students are there in the program? So since there are 2 groups, it's going to be a little bit confusing. So what we do is that the junior high and SH high, there are 26 students in the entire program, and in the science program, in the science group, there are 20% of the junior high students and 12.5% of the senior high students. And in the science group, the 2 groups have equal amount of people. So since it's going to be a bit confusing if we use junior high and senior high, let's use substitution as well and just replace them as x and y. So what we know is that x plus y equals 26. So in this case, x and y are the junior and senior high students from the entire program, not just the science group. So it means that x plus y is equal to 26, and 20% of x is the same as 12.5% y. So we can convert these into fractions first, and as we know, it's going to be 20 over 100 equals 1 over 5, and for this it'll be 12.5 over 100, which might be a bit hard to calculate, so we can just multiply it by 2 over 2 to get 25 over 200, which when simplified is 1 over 8. So now we have 1 over 5x equals 1/8y. In order to make these integers, we can just multiply them by 40, which is the least common multiple, to get that 8x equals 5y. So now that we know this, we can plug it back into our original equation, which is x plus y equals 26. And the way we do it is that perhaps we could multiply this equation by 5 to get 5x plus 5y. I'm going to move it equals 130. But we also know that 8x is the same as 5y, so we can just replace this with 8x to get that 13x equals 130. So that means x equals 10. But we want to know how many senior high school students there are, which is y, and that would be just 26 minus 10 equals 16. So that will be our final answer. Do you guys have any questions? If not, we can move on to a 5-minute break, and I'm going to set a timer. So I'll see you guys in 5 minutes. Is everyone back? So I see that most of you guys are back. So regarding this type of problem, I'm actually going to explain a second problem just in case you guys don't understand, because the type might be a bit confusing. So in this one, it says that in a school's dance team, the number of second grade students is twice that of fifth grade students. Among the 180 students in 2 grades, 1/5 of second grade students and 10% of fifth grade students join the dance team. How many fifth grade students join the dance team? So let's say this is the school's dance. This is like the entire school. Then there would be 180 students. And there is a dance team inside. So the number of second grade students is twice that of fifth grade students. So let's say second is X and fifth is Y. So it says that there are 1/5 of second students, 1/5 X, and 10% of the fifth grade students, which is 10 over 100, and that would be 1/10. So it says that in the dance club, the number of second grade students is twice that of fifth grade students, which means that would be 1/5 X equals 1/10 times 2 equals 1/10 Y times 2. Sorry. Equals 1/5 Y. So that means that there are the same amount of students So that means that the amount of students of second grade and fifth grade in the entire school are the same. So that would be X equals Y equals 90. Because X plus Y originally was equal to 180. So since there are 10% of fifth grade students that join the dance team, it's pretty simple. 90 divided by 10 equals 9, and the answer is 9. So now we can finally move on to the practice problem. I'll pull it up real quick. And give you guys some time to do it. Yes, do you have any questions?
So are the 8th grade students supposed to be junior high?
Yeah.
Okay, thank you.
Okay, the time's up. See that most of the people who participated got it correct, but since it's a little bit of a complicated type of question, I'll explain it. The question says that in a high school, a basketball team was formed. The number of 8th grade students and 9th grade students in the team is equal. So firstly, there's a high school which consists of both 8th grade and 9th grade. Let's say 8th is X and 9th is Y. So it would be X plus Y equals 150 because it says that there are 150 students in both grades. And among these 150 students, there is a basketball team. So let's say it's in this circle. So this says that there are 30% of the junior high students, which is the 8th grade, and that would be 30% X. And there are 20% of the senior high students, which is 20% Y. So it says enter the basketball team, and it says that the number of 8th grade students and 9th grade students in the team is equal, which means that 30% X is equal to 20% Y. So let's take that out. And by converting it into fractions, we have 3 over 10x is the same as 1 over 5y. And by multiplying them both by 10 to get integers, we have 3x equals 2y. And because it says that x plus y equals 150, we can plug this in. And the way we do that is by multiplying this equation by 2. That will get us 2x plus 2y equals 300. And because we know that 2y is the same as 3x, we can replace it with 3x, and eventually we have 5x equals 300, which means x equals 60, and the answer will be 60. Do you have any questions? If not, we'll move on to the fourth concept. The fourth concept is about faction-based pairing between two groups, and I feel like these types of questions are also a bit confusing. Usually, two groups are partially paired based on known faction from both sides, and we need to use this relationship to find the number of individuals. An example, just so you guys can get to know it better, is this question. In a school club support project, some second grade and 5th grade students form mutual assistant pairs. Each 5th grade student could have 2 second grade partners. If 1/4 of the 5th grade students and 1/3 of the second grade students form pairs or groups, then what proportion of the total number of second grade and 5th grade students had partners? So first, again, let's use some substitution. The second grade students are X and 5th grade are Y. So the people that are involved is going to be 1/4 of X and 1/3 of Y. But in this case, it says that each 5th grade student could have 2 second grade partners. So that would mean that 1/4 X is corresponding to 1/3 y times 2 equals 2/3 y. Or in fact, and we would get that x is the same as 8 over 3y. By multiplying these by 4. So that would mean x is 8 over 3y. And now that we know it, we need to find our answer. It asks what proportion of the total number of second grade and fifth grade students had partners. So we would need an equation. The number on the bottom is going to be x plus y because the total number of fifth grade and second grade is x plus y. And we need to know what proportion of that total number of students have partners, which is going to be 1/4 x plus 1/3 y. But now that we know x is the same as 8 over 3y, we need to plug that in. And in order to do that, we'll have 1/4 x times 8 over 3y equals 2 over 3y. Which means that this is going to, so this would be 2 over 3y plus 1 over 3y, which is also just 1y. And at the bottom, we will do the same. So x is 8 over 3y, so that would be 8 over 3y plus y, which is the same as 8 over 3 plus 3 over 3y equals 11 over 3. So eventually we have y over 11 over 3y. And it might seem a bit complicated, but if we turn it around, eventually it's just going to be y divided by 11 over 3y, and that would be y. And because we have y on both sides, we can just cancel that out. And eventually it'll be 1 divided by 11 over 3, and that will get us 3 over 11. And in this case, the answer would be 3 over 11. And this actually has it wrong. It's supposed to be 3 over 11 instead of 10, and that will be our answer. If there are no questions, there is also a second example that of the same type, and I think this one is a bit easier than the last one because of the numbers. So it says that students from 2 different schools are participating in a math competition, and each student must be on a team with exactly 1 student from the other school to participate in the competition. So that means that each will only have 1 partner, and the number of students who have partners on both teams are going to be the same. So it says that there are Team A and Team B. It says 3/4 of all students from School A are on a team, and 1/4 of all students from School B are on a team. So that's pretty simple. We can just say 3 over 5A is the same as 1 over 4B. And in order to make it the same, we can multiply it by 20 to have 12A equals 5B. So we have to choose one to isolate. Let's say B, then we can have B equals 12 over 5A. Right. And we need to know what the final equation is going to be. So that would be A plus B on the bottom, as we know, and 3 over 5A plus 1 over 4B on top. So now that we know B is the same as 12 over 5A, we can plug it in. For example, for this one, it would be, we can replace that with 1 over 4 times 12 over 5, which is the same as 3 over 5. So that would be 3 over 5A. And at the bottom, we'll do the same. A plus 12 over 5A is the same as 12 over 5 plus 5 over 5. And that would be 17 over 5. So now we have 3 over 5 divided by 17 over 5. And that would be A, but since they just cancel out, we don't actually need them. And that would be 3 over 5 times, that times 5 over 17 equals 3 over 17. And that would be our final answer. So if there are no questions, then we can move on to a practice problem. actually one person got it correct. And because like of the phone numbers, I'm not sure like who it is because I don't know the name. But anyway, congratulations. And it's a pretty confusing question, so I'll explain it instead. Again, there are two groups of people, and each first year student could bring along two fourth grade students. There are 1/5 of the first year student and 2/7 of the fourth grade student who formed groups. So let's say X and Y, as usual. First is X, and fourth is Y. Then we have 1/5 X and 2/7Y. Because each first year student could bring along two fourth grade students, it means that 2 times 1/5 X is the same as 2/7Y. So that would be 2/5X equal 2/7Y. And because they have the same numerator, we can just say 1/5X is the same as 1/7Y. In order to make it easier for us to comprehend, we'll multiply them by 35 to get 7x equals 5y. So that would mean we can isolate x and get x equals 5/7y. Now let's create the equation for our solution. The number on the bottom, the denominator,